Welcome back, everyone. In this episode, we are pushing these two circles apart from each other. Right now, we can just move them and intersect them. We get a collision, but the other circle is not moving away. And I'm going to show you how we can do that. For this, let's jump back to our code. Okay, so the first thing I'm gonna do is go back to our collision detection method for the circle versus circle, or to the circle versus circle, and um, I'm gonna save the distance from standroid A to standroid B in a variable called direction length, and that's just direction length. Of course, we can also, because if you're gonna call this here, it doesn't make any sense to do a optimized check for that. So we can just move that in here too. So we can first check with the optimized way if there's a collision. And if not, then yay, we saved some performance. And if there's a collision, then this small multiplication doesn't matter at all. Then we can do the heavy calculation with the square root. But as I said, for this course, it doesn't really matter to do length 2 or length. Maybe it does make it's gonna make some things more difficult to understand. But basically you can use the normal length method too instead of length squared. But yeah, for this example, I leave it like it is. And yeah, do the things the optimized way. Okay, so now we can calculate the depth, or I'm gonna call that penetration depth. And this is gonna be the direction length minus the sum of the radius, and we already calculated that. So I'm just using this variable, sum radius, without the curly brackets. There we go. Now we have the penetration depth. And now, instead of returning true or false, oh, I'm sorry, we also need to calculate another important thing, and that's the normal direction. It's also sometimes called the penetration normal. And that's the normalized direction I talked about in the short drawing I made in the previous episode. And the penetration normal is the normalized vector from the center to the other center in this example. Usually it's a direction from the actual penetration point, which is intersecting with the other object from the center. So it's the normal which is used to move the objects out of each other. And in this case, it's just a normalized direction vector between the centers of the circles, between the center of the circles, yeah. And we can calculate this pretty easy. It's just direction. Well, actually, I need to take a look into the vector class. Yeah, if I'm gonna call normalized here, just gonna normalize the direction. So I'm gonna do that manually by calling scale because scale is returning a new vector. And I just say direction and multiply that with 1 divided by the direction length. And then I basically normalized the direction. And I spelled that wrong again. Okay, that's nice. And now we're gonna change our return value here. It's not gonna be a boolean anymore. It's now gonna be a class. If there's no collision, I'm gonna return null. And if there's a collision, I'm gonna return a new collision manifold. Just need to make sure that I spelled it right. Yeah. Okay. And in there we have a depth, a normal, and a penetration point. And the depth is gonna be, of course, the penetration depth. And here I'm gonna multiply that by -1. This is important. The collision manifold always needs to be the same, not the same values, but the same sign. Because if you're gonna do another method, for example, circle versus polygon, and we are returning a penetration depth, we cannot return different penetration depths in terms of one depth is minus and one depth is plus. We can't do that. We always need to return the same sign. And I'm gonna multiply this here by -1, so we have a positive penetration depth. Of course, you can change that method to calculate a plus penetration depth, of course, if that's more convenient for you. And actually, we could do that here, of course, but in my source code, it's also a little bit different. It's with that minus sign, so I'm gonna leave it like this. And then, of course, we need to pass in the penetration normal. Well, and the penetration point, but we don't have that right now. And the penetration point is the point where the circle is intersecting with another one. And this point is normally or has a depth to the border, the has a minimal depth inside. Maybe I can show you that again with the presentation. Just 1 second, so that you know what I mean. There we go. When we take the radius b, the arrow, the penetration point would be this point here. And the penetration point for the circle A would be here. Yeah, that's what we're going to calculate for now. Later, it's going to be, it's going to make more sense later, because this could be a little bit tricky then. So I'm going to warn you, but I think we are going to get this. All right. So let's go back to the code. Oh, 1 second though. There we go. Okay. Okay, we can calculate the penetration point. Just by adding one center. I'm gonna use the centroid A. It's also important where the penetration point is, how we calculate that. Because we're gonna use the collision manifold. The collision manifold must have or it's the same structure, I call it. Just like the penetration depth. If something is wrong in one of these methods, then we get really strange behaviors. But I'm going to show you I'm going to show you later on what I mean with that. Okay, so let's calculate the penetration point, and that's pretty easy. We need the centroid. For one circle, I'm going to use the centroid A, and then I'm going to scale the penetration normal by the no, not by the penetration depth, by the radius. And make sure you use circle A radius. Okay, and that's the penetration point. And that's the method for circle versus circle. Okay, then we can go back to the simulation class. And in this, I first create okay, result is gonna be the collision manifold. And with this one, we can push now the circles apart from each other. So let's make another variable called push. And I'm gonna scale this one, or I'm gonna calculate this one with the result dot normal by the result dot depth. And then I'm just gonna call this dot test circle B dot move by the push vector. Just to make sure, the penetration point, we're not gonna need that now for for the pushing part, but we are gonna need, especially for polygons, we need the penetration point for calculating the impulse vector later. So we're not gonna need it now. Okay, and that should be it. Yeah, what I forgot. What's also quite good is to draw debug information, and that's why I have a draw method inside the collision manifold to show some, well, to show some debug information basically. And I want to draw an arrow from the penetration point in the direction of the center to see how much, or to see that the penetration is actually calculated right. So I'm gonna do that by defining a variable called start point, and this is going to be the penetration point scaled by not scaled, I mean of course added from the penetration point. I'm gonna add a new vector, and that's gonna be the normal times penetration depth minus 1. And then I'm gonna draw a arrow with draw utils, draw arrow, and that's the start point. Then the penetration point, and I'm setting the color to blue. And I also draw the penetration point with a color of gray and a radius of 3. Okay, So I'm just gonna make sure that I did everything right. I probably not, because I think it's not gonna work the first time I'm gonna refresh the page, but let's see. Of course, yeah, we need to draw that manifold too. And I'm gonna do this like this. I'm gonna make a new variable called list.collision. We're gonna change that later. Now, well, actually, I'm gonna just put it in here. Oh, of course, it doesn't work. Then in here, and I set that every time to null. This is just a temporary thing. I'm gonna change that later. And then I'm gonna set this one to the result. And then in the draw method, if list.collision manifold is this, if it's not null, then we're gonna draw that. Okay, let's see if that's working. Developer tools, go to the browser, make sure you saved everything, and refresh. Okay, no error till now, and then I'm gonna move it into that circle, and there we go. We have a really interesting effect, and that's normally done or fixed by multiplying the normal or the depth by -1. It's a typical problem you always come along when implementing a collision detection and resolving the collision. And yeah, that's probably most probably a problem of a wrong depth or a wrong scaled normal. Okay, so let's jump back and see if I did something wrong there. We are calculating the direction length, that's right. The penetration normal should be also right. Penetration depth looks also good. The penetration normal point, we're not gonna use this one. But probably, yeah, I found the error. The direction is simply wrong. We are subtracting a minus b. Of course, you can do that, but we need to change some things then. So for this example, I'm gonna subtract b from a. Collision detection should be the same, should work the same, but this time we should see some pushing, or let's say the right pushing. Okay, then jump back to the browser, refresh the application, and let's move the circle again. And there we go, we can move the circle from each other, or the big, the small one. When I use the small one, I think it shouldn't work, right? Yeah, because we are only checking the bigger circle against the smaller one, but not the other way around, and that's why it's not working with the other one. But that's usually not a problem. It's gonna work later on. This is just for testing purposes. Of course, if we go back to Visual Studio, to Visual Code, we can do also a checking to the other circle. and push that also apart, it should work the same. Yeah, but that's for this episode. I hope it was clear and understandable. And then, yeah, then we can calculate actual normals of a polygon, because the normals of the polygon are used to make a collision detection between them. Yeah, have a nice day and see you in the next one. Bye.